In this video, we're going to be solving for x, where x is located in the exponent in an equation. Normally, people look at an equation like this and think that they have to use log, but as long as you're able to rewrite both sides of your equation as the same base raised to a power, then you can use something called the one-to-one property. So the first example is really simple. I have 2 to the x equals 8. So you're really asking yourself, 2 to what power equals 8? So I want to be able to say to myself, can I write 8 as a smaller base, a smaller number raised to a power? And whenever possible, we want to make the base as small as possible. 8 is actually 2 to the third power. So it would be pretty good practice to go over all of your bases to different powers. So what do I mean by that? 2 to the second is 4, 2 to the third is 8, 2 to the fourth is 16, and so on. So make sure you know these really well, because it's going to help you move along a lot faster when you're solving more intricate problems. Okay, I'll do a few more on the side here. We have 256. You should honestly know these by heart, okay? 2 to the 9th is 512, and 2 to the 10 is 1024. If you've ever played, there's some game on the phone. 1024, was it 2048? I don't remember. 3 to the second is 9, 3 to the third, 27, 3 to the fourth is 81, and 3 to the fifth is 243. What am I writing? Sorry. I started thinking 7 to the third for some reason. So 243. And I'll just leave those on the side for now. Okay. So if I know 2 to the x equals 2 to the third, the one-to-one property basically says that if you have one base of, in this case 2, on each side of the equal sign, then you can basically conclude that the exponents have to equal each other. Therefore, x equals 3, and we're done. That's your answer. Okay? The next example is a little bit more involved. So this side's already a nice, simple number to a power. 27 I can rewrite, so I'm going to leave the left side as 3 to the x squared plus 2x, and the right side I'm going to write it as 3 to the third, 1 to 1. I have 1 3 on each side, so I'm going to ignore the 3. You're ignoring it, you're not dividing by it, you're not subtracting it, okay? You're just ignoring it, and you're only comparing exponents. X squared plus 2x has to equal 3. This is a quadratic equation, and like all polynomial equations, in order to solve it, we need to get it equal to 0, factor, and then use zero product property. X squared plus 2x minus 3 is 0. Factoring this, we'll use 3 and 1, so it'll be a positive 3 and a negative 1. And I'm not going to write out every step, but I'm really setting each of these equal to 0, and we get 2 answers. I'm going to get x equals negative 3. Here's one answer, and x equals 1. There's my other answer. So I have 2 answers for this problem. A lot of times people guess and check, and they just get 1 to work, and they're like, oh, that's awesome, I'm finished, but really there's 2 answers in this problem. Okay, next examples. We have a few examples here. So that was our first example. Second example, here's our third one, and actually another one underneath it. So this one's a little bit more involved. I already have 5. It's nice and simple. It's to the 2x squared, and can't really do much with that. That's my exponent. Great. Times 25. I'm going to replace 25 with 5 squared. And this is a 3x plus 1 out there. Now when you raise something to a power and then raise it to a power again, that whole quantity, what do you do with the exponents? Think about it. I'll get to it in a second. Here, 125, well, 125 is 5 to the third. But 1 over 125 is 5 to the what? I'll get to that in a second. Here's 5 to the negative x. Okay, now that you've had some time to think, let's start filling in some pieces. I'm going to write what this is in a second, but I'm going to give you time to think about it. Here, what we're going to do is your answer should have been that you multiply. Okay? When you raise something to a power and raise a power again, you multiply the exponents. And what do you do when you multiply like bases? You add the exponents. Okay? For example, x squared times x cubed. That is x to the 5th versus x squared cubed. That's x to the 6th. If you have to know those two examples in order to succeed at something like this, then just make sure you know those examples really, really well, okay? So what will that give me? Let's do a couple steps at once. This is going to become 6x plus 2, right? We're going to multiply. Then this is going to add. So my whole exponent is 2x squared plus 6x plus 2. Now back to this. 125, that's 5 to the 3rd power. 5 times 5 is 25, times 5 is 125. 1 over 125 is 5 to the negative 3rd power. Negative exponents, if you remember, kind of brings it down to the denominator. Now here, I'm going to add negative 3 and negative x. What does that give you? Negative 3 minus x. There we go. It isn't until you have it written like this that you can use the one-to-one property, because again, you're only allowed to have one matching base on each side. Here we have 4 of them, right? That wasn't correct. So now I'm going to set my exponents equal to each other, because 5 to this power equals 5 to that power. These are one-to-one functions. That means it passes the vertical and horizontal line test. You may have talked about that in algebra, but I'm not going to elaborate on that right now, okay? It's more of a review, assuming you know those things. I'm just trying to refresh your memories. 2x squared plus 6x plus 2 has to equal the negative 3 minus x. Quadratic equation, and again, like all polynomials, we have to get it equal to 0 and solve by factoring. So bringing it over here to save some space, that will give me 2x squared. If I add x, I'm going to get plus 7x. If I add 3, I'm going to get plus 5 equals 0. Quadratics equal to 0, we're going to factor and solve. 2 is prime, so I have a 2x and an x. 5 is prime, so I'm going to have 5 and 1. Now if I put a 5 here, I'll get 10 and 1. That won't give me 7. But if I put the 1 here and the 5 here, I get a 2x and 5x, which totally gives me 7x. Does it work when they're both plus? Yes. Then you set this is the zero product property. I'm setting this equal to 0 and this equal to 0. What does that get me? X equals negative 5 divided by 2. And x gives me, solves out to be negative 1. So here I have 2 answers for this one as well. Alright, now we have one more example. For this one, it's quite simple because it's already set up to have 6 on each side as the base only one time. So we're already ready to set the exponents equal to one another using the one-to-one property. So negative 6x minus x squared must be equal to 8. Polynomial, I'm going to get it equal to 0. I'm going to bring everything to the right side so I have a positive x squared to work with. So it's x squared plus 6x, and the 8 was already there, so it's positive. Factor, that gives me x plus 4, x plus 2. 0 is equal to x plus 4. We're going to solve zero product property, and I'm also going to set x plus 2 equal to 0. However we write it, x equals negative 4 is one answer, and x equals negative 2 is the other answer. And that's all we have for that.